Okay, thank you very much, class, and all the organization of the webinar. Shall I keep the camera on?
Yes,
like
you can keep it on if you want. It's
good. Yes, yeah.
Nice.
All right, good. Thanks again for the introduction and the invitation here. It's a pleasure to present some of the results from the C3S Energy contract or project or whatever we want to call it. It's an operational system that is running on the C3S. So today we're going to look at a bit at what this service is about in the context of projections. But before we get there, I just want to show a bit of the rationale for developing this climate service, which is like, I guess, other climate services for under the CIS in C3S, the services for individual sectors. We want to engage with users directly with the energy sector. And so what we've done in the lead up to the C3S Energy operational service, we've done a lot of interaction, a lot of stakeholder engagements and so on to understand what the requirements are for such a service. Of course, it's not going to be pleasing everybody. It's not answering all the questions, but it's a good start for some data that can provide food for thought analysis and initial investigations on what is required for the energy sector. So this is basically what this slide says. In a nutshell, the service is composed of 3 streams. We have the past, kind of present with seasonal forecast, and the past is with reanalysis going back to 1979 at present, and perhaps we can extend later to 1950 with the extended EURO-5, and then we have projections out to 2100. So the 3 streams are done with climate variables and energy variables or indicators, and all variables that are relevant in the terms of climate for energy. We're not covering the full spectrum of energy because it's very, very broad, but we are addressing mainly electricity and particularly renewable energy, apart from the demand, which is all encompassing. So we've got, in terms of climate, we have temperature, precipitation, wind speed, and solar radiation, and for some variables, pressure, mean sea level pressure. And in terms of energy indicators, we have electricity demand, wind power production, both for wind onshore and offshore. We then have photovoltaic production, so that's the only solar. We don't have CSP, for example, because of the size of the installed capacity. It's pretty small at the moment, so overall, apart from little pockets here and there. And hydropower production is divided into run-of-river and reservoir. Okay, so before we jump also to projections, which is what the focus of this webinar is about, we need to take a step back because unfortunately, we don't have many observations of energy for the future. So we are relying on the little we know about the past. Energy data are available since a few years ago. It's easier to get them, but still very small in quantity compared to climate. So we're doing our best to collect all the best information available mainly from ENSTOI, the European TSO, so the Transmission System Operator group, and then we need to provide some models that produce this indicators, the demand and the production, like I mentioned. We adopted different approaches depending on the availability of data and the quantity that we are looking at, the indicator. So we have a mix of statistical models and physical models. I won't go into very much detail. I'll give you the references later because there's a lot to cover in this 50-minute presentation. So let me get on with the rest of this. But the main thing about the models is that we're looking at the flexibility of the conversion models rather than full accuracy. So we also, in terms of scales, we're not going down to individual solar power plants, for example, or wind power plants. So if you are looking for that, you'd be disappointed, I'm afraid. But at least you'll have some indications of what can be done to achieve that. And we can also discuss later at the question and answer. So some results, I'm not going to details of the models because I said I'll give you the results, but I want to show you how good the models are. And this is also presented in a recent paper that has been submitted. And if we look at the electricity demand, we put down the demand at the national level. That's where the data are available. And for all the, or most of the European countries, like shown here, and in most cases, the results of this demand model is very good. So we're still looking at the historical record because, as I said, we need to tune the models for the history first. Once we do that, the idea is that we apply the same methodology for the projections for all models. So that's the approach we're taking, regardless of the type of models that we are using. Then we go to the wind power validation, and we can see here that we got kind of mixed results with better results in kind of Northern Europe, but also Spain and Portugal. Italy, Switzerland is less so, and this is partly to do with installed capacity. Like Switzerland has a lower installed capacity. It's also very mountainous, as you know. And the other factor is that we are not adjusting the wind speed from EURO-5, which is the basic data that we use for all our simulations. And then we know that the wind speed has some limitations in some parts of Europe and elsewhere from EURO-5. So some bias adjustment would be required, but it's not done here. However, we try to adjust the results also based on the energy data. So that's also the purpose of looking at this results. In terms of solar power, here we have, so in terms of wind, we have a physical model. It's a rather simple model, a standard one. In terms of solar power, we have a mix of statistical and physical model. So it's possibly the most complex of all models we have adopted here in C3S Energy. And it still gives pretty good results here, despite the fact that there are so many variables, inclination of the solar panels and location and all these things. So we are pretty pleased with the results overall. They're not perfect, but they are generally pretty good here at the country level again. And then in terms of hydropower, that's a similar story. Not all countries have a hydropower, so you see fewer scatter plots, and we have on the left here, at the top a reservoir, the bottom run of river. So these are the two types of hydropower that we considered. The third one being pumped hydro, which is not very much correlated with climate variables, so there's not much point in trying to model it in the same way we are doing here, which is basically trying to see what the climate drivers are. And this applies to all models, by the way, so it's not just the hydropower. We're trying to isolate the component of climate that drives the energy models. That's the other underlying assumption and approach that we are taking in this C3S Energy. Results here are, without going into the details, again, are pretty good. We compared here different type of models, and the results overall are good. So I'll jump here to the kind of summary of this assessment. And the validation confirms that the simulated data are plausible. They're not perfect, but they are good enough for the type of exercise that we are doing, and to provide some initial indicators for assessment of energy at various scales. I didn't mention the scales for all the indicators, but I encourage you to go, just in the interest of time here, I won't go into that detail. The validation is hindered by uncertainty in the reference data, energy data particularly. There are still quite a lot of limitations in the way that data are provided, but we've been working closely also with the data providers to improve that, and so we achieved quite a good result in that respect as well. And an update of the models is needed to improve the simulations. Yeah, there's always improvements, but some are, for example, removing some of the areas that we know we couldn't build, for example, a solar power plant. At the moment, we are treating all areas equally, which is obviously a gross approximation, but still works relatively well at the moment, and need for quality control. And the references under here. So the first one is regarding the solar power model, the second one, the hydropower model, and the third one brings them all together in a massive paper, which describes all the results that I've been mentioning here. So it's actually not published yet, but watch this space, and hopefully will come out soon, and you can look at it and ask many questions. Now, in terms of projections, the system works in an operational way, as I said, and they're being operational, there are many steps to get there, and I won't bore you with the details here, but just to show you the complexity of the system underneath. And to get there, we've applied some bias adjustment to projections. We used the quantile mapping, and these are some of the results for winter temperature. Again, I won't have time to go at the level of detail to show you the differences and so on, but you'll have the presentation and you can check it on your own time. In terms of, also, we used about 10 models for projections, all EURO-CORDEX models. They've been pre-selected. There are a few more, but it's depending also on the availability of the data and resolution that we required, particularly the temporal resolution and the variables we needed. We got 10 models, and this is what looks like in terms of climatology of temperature, and in this case, in terms of temperature versus quantile for the 10 models. So we see a shift, of course, to higher temperatures, but still some probability for a range going to kind of current day climate. We adjusted in the same way all the variables, so the temperature, precipitation, wind speed, and solar radiation. So being a non-parametric bias adjustment, the quantile mapping can be applied quite equally to all the variables. Here are some results for the solar radiation, and this highlights some of the changes between 2050 and 1985, bearing in mind also that there is studies, there are paper, I have a reference here, but they show that the trends in solar radiation in EURO-CORDEX is actually the opposite of the driving models from the GCMs. So there is possibly quite a lot of uncertainty here that needs to be looked at for some of you who are interested in these matters. There's a lot to do, and then using the data that are being produced. This is an earlier version of the system, but still, it's the principle applies. There's this paper that looked at the sensitivity of the European power system, particularly for demand and wind power and solar power, according to the various models provided and various scenarios for energy. So while the energy scenarios vary quite a lot in time, so in the future, because of the technology drivers and other drivers that are not related to climate. The climate, as is shown in this paper, the climate driver is still an important component when it comes to any choice that is made for a particular type of power system, future power system. There are, you can see here in the case of wind power, there's much more uncertainty around the signal. And on the top right, solar power instead is a bit more confined. The signal in wind power is relatively small, close to zero in most cases, so no major changes from now until 2050 or thereabout. But for solar power, there are some expected changes. This is European-wide. In the paper, we also show some regional country level, because we know for solar power, for example, we have a projected increase in Southern Europe and decrease in Northern Europe, although there are also competing effects to do with increasing solar radiation, but also increasing temperature, which lead to compensation in the increase of solar power. So increased temperature will tend to limit or lower the increase in solar power to do with increased solar radiation. Okay, so the next slides are just some examples of what you can achieve with the data provided. So I'll just provide a few examples, and then you can go and play for yourself. I want to start from this tool that has been developed under C3S, but it's now it's not being updated, but still contains quite a lot of data. And this actually are the data that have been used for the paper I just described. So there's potentially a lot more that can be done with all the data here. And like in this case, I'm showing, for example, how you can plot, and then you can also retrieve all the data. There's an option to retrieve all the data here. And you can see like a temperature increasing for Italy, whereas on the top left, whereas for global radiation, there's no major trend. And for solar power at the bottom here, the capacity factor is slightly declining, partly because of the increased temperature, or mainly because of that. So these are some of the things you can look at. Then another development that was done is this education demonstrator, again under C3S. And here you can find similar type of data, but displayed in different ways. And so maybe easier to approach. The previous one was kind of rather technical. If you're not too technical, maybe this one is easier for you. Okay, so moving forward, then we move to the latest and development here under C3S. And the data at the moment for projections are not quite available. They will be soon. We always say soon, so don't ask me when. But at the moment, you can play with and download the data for the historical period. So this is the historical stream, the one of the three I mentioned, and that's what is also used to test all the energy models. So here you find the description and the data to download, and then you can go and play with the data explorer, and you got different options here to plot. Again, here I focused on solar power. And at the top, you get the map, and at the bottom, you can plot the time series for two variables. And in this case, it's solar power against solar radiation. So you can see they are pretty highly correlated as expected, but they're not one-to-one, let's say, as one might expect, partly to do with temperature effects and probably other factors as well. Okay, so and then if you want to play even more, there is also this new tool that we developed at WEMC, again based on C3S previous developments, but also from another European project called Secli Firm, and we are developing this for the moment is climate. I will soon include also seasonal predictions and then projections. So if you like to play with this and send us some feedback, that would be much appreciated. And as you can see, also we try to simplify here the view and make it as easily approachable as possible. Okay, just to conclude, I think this is probably the last one. I just want to mention that all the things that have been described are documented. Most of the things are documented are on papers or documents that are available through the CDS at the links provided. So we got variable fact sheets, one per each variable. And we have other descriptions about the methods and limitations, bias adjustment, how it was done, and a user guide for seasonal forecasting, which is probably the most complex aspect of this service. Although there is also other parts of C3S that develop seasonal forecasting, so there are complementary documents here. We also developed case studies and key messages, FAQs, tutorial videos, and so on and so forth. So I think, yeah, this is the last. So if you want to know more, here's the link at C3S for the operational service for the energy sector. And we also have other related activities at WEMC. So that's the link. And I think that's what all I wanted to say. Thank you very much.